Hello students, welcome to another class where we are going to solve previous year JEE Mains questions specifically of motion in 2 dimensions in today's class, and that is from the series January 2025 and 2024, both April as well as January shift. Alright, so now you know what are we doing today. Of course, recommending again that you should watch the theory videos first, try the questions of JEE Mains yourself first, and then go for these video solutions. So now without wasting any time, let's get started. Put down the heading JEE Mains in January 2025 and 2024 series motion in 2 dimension. Alright students, so the first question is from 29 January shift 1. Two projectiles are fired with the same initial speed from the same point on ground at angles of 45 minus alpha and 45 plus alpha. So that's clearly a case of complementary angle projection. Okay, the ratio of their maximum heights attained is, so one projectile is fired at 45 minus alpha and the other is fired at 45 plus alpha. So of course, since these are complementary angles, they both will land at the same point, hence the range of both the projectiles is going to be the same. So if they would have asked the ratio of the range, then the answer would have been 1:1. But they have asked us the ratio of their maximum heights. Alright students. So of course you know the formula for maximum height. Let's apply that. So it is going to be u square sine square 45 minus alpha over 2g divided by u square sine square 45 plus alpha. So one of them is 45 minus alpha, the other is 45 plus alpha. So this ratio turns out to be sine 45 minus alpha divided by sine 45 plus alpha. Alright students, whole squared. Now I will use two identities here. So if you are a NEET aspirant, you should know this, that sine A plus minus B is equal to sine A cos B plus minus cos A sine B. So this is the first thing that I'm going to use. Secondly, of course, you know this identity hopefully, that sine 2 theta is 2 sine theta cos theta. So let's use both of them. Now what is the ratio? So h1 over h2, the ratio is going to be, so h1 over h2, this is going to be, so sine 45 is like 1 by root 2 and cos 45 is also 1 by root 2. So this is going to be 1 by root 2 cos alpha minus 1 by root 2 sine alpha divided by 1 by root 2 cos alpha plus 1 by root 2 sine alpha and squaring this, right students? So 1 by root 2 factor will cancel out from numerator and denominator, and what we are going to get is cos alpha minus sine alpha divided by cos alpha plus sine alpha whole squared, right students? So this is going to be cos square alpha plus sine square alpha minus 2 sine alpha cos alpha. So we can write this as 1 minus sine 2 alpha divided by 1 plus sine 2 alpha, of course using the identity that 2 sine alpha cos alpha is of course sine 2 alpha. So very easy students, the answer should be option B, that's clearly showing, right? So copy this down, then we move to the next one. Alright, so every time I show you the question, you pause the video and try it yourself first. This is from 24th January shift 2. The position vector of a particle at any instant of time is given by r is equals to 5t square I cap minus 5t j cap. The magnitude and direction of velocity at 2 seconds is going to be. Alright, so if we have the position vector just to get the velocity vector, let's differentiate this with respect to time. So that's like dr by dt, can't get easier than this. So this is going to be 10t I cap minus 5 j cap. Now particularly at t is equals to 2 seconds, this is going to be 20 I cap minus 5 j cap. So having a component of 20 in the x direction and 5 in the negative y direction, giving us a resultant like this. And this resultant is of course under root of 5 square plus 20 square. So that's like under root of 425, which you can of course write as 5 root 17, right students? So what about the angle? So if we look at the options here now, so 5 root 17 is available in option C and option D, but it's not A and B of course. Now the angle is given as tan inverse 4. So I do understand that they are talking about this angle, let's say alpha. So tan alpha is equals to 20 by 5, that is 4. So alpha is like tan inverse 4, where alpha is the angle that it makes with the negative y-axis. So the correct answer should be option D, my dear students. So 5 root 17 making an angle of tan inverse 4 with the negative y-axis. No doubt whatsoever. I hope you should be able to do it. Alright students, so the next question. This is from 22nd January, shift 2. A ball of mass 100 gram is projected with a velocity of 20 meter per second at 60 degree with the horizontal. Be always careful about this. Sometimes they give you the angle with the vertical also. The decrease in kinetic energy of the ball during its motion. So I have taken this question here because kinetic energy, of course, you know, is half mv square. So what we have done is we have projected the ball with a speed of 20 meter per second, making an angle 60 degree. Now what happens is, at the highest point, the velocity that we are left with is 20 cos 60, because you understand at highest point the vertical component becomes 0 and it is only the horizontal component that exists, right students? So this is going to be 10 meter per second, while the initial velocity is of course 20 meter per second. So mass is given as 100 gram, that is like 0.1 kilogram. So initial kinetic energy is going to be half mu square. Now what is the value of m, my dear students? So it is 0.1 and u square is going to be 20 whole square. So this is going to be like 400 into 0.140 divided by 2. So it's going to be 20 joule, right? While at the highest point, kinetic energy is going to be half m v square, and instead of v square I will only write the horizontal component because the vertical component has become 0. So now this kinetic energy is going to be half into 0.1 into 10 whole square. So that's like 10 divided by 2, so that is like 5 joule. So we started off with a kinetic energy of 20, at highest point it has become 5. So the decrease in kinetic energy is of course 20 minus 5, that is 15 joule, my dear students. Alright, so the next question is from 22nd January, shift 1. A particle is projected at an angle of 30 degree from the horizontal at a speed of 60 meter per second. The height, so they are talking about the height only, traversed by the particle in the first second is h naught, and in the last second before it reaches the maximum height is h1. Looks quite simple to me. Let's visualize this. So they are talking about first the starting point and then one last second before it hits the highest point. So first let's calculate what is the time taken to hit the highest point. So of course if the total time of flight is 2u sine theta by g, then the highest point is going to be u sine theta by g. Now u is like 60 sine 30 divided by g, right? Because if the total time of flight is 2u sine theta by g, air resistance is ignored, so the highest point it's just half the time. So this is going to be like 3 seconds. So it takes 3 seconds to reach the highest point. Now they are talking about the height. So let's first calculate the vertical component of velocity, which is going to be 60 sine 30 because it is being projected at 30. So this is going to be like 30 meter per second, right? So that is the vertical velocity. Now I will just use the equation of motion. So h naught is equals to ut plus half a t square. The value of gravity has to be taken as 10 and initial velocity in the y direction is 30, and we are talking about the first second, right? So in the first second we get h naught is equals to 30 minus 5, that is 25 meter. Now what is h1, my dear students? So h1 is like what it travels in the last second before it hits. So it is like the third second. So I will use the formula s nth is equals to u plus a by 2 into 2n minus 1. I think that's the easiest way to do it. So u is like how much? U is like 30, u plus a by 2 into 2n minus 1. So it is like the third second. So I will write n as 3. So this h1 becomes 30 minus 5 into 5 is like 25. So it is going to be 5 meter. So it travels how much, students? 25 in the first second and 5 in the last second. So the ratio of h naught over h is like 25 divided by 5. So the correct answer should be 5. So we have to fill in the numerical answer. So the answer should be 5. Right, students? So the next question. is from JEE Mains 2024 now. 8th April shift 2, the angle of projection for a projectile to have the same horizontal range and maximum height. I think all the students have done this question, and every teacher will make the students do such a question where they are talking about equating the range and maximum height. So there is a coincidence that the range and the maximum height become equal. So it is like u square sine square theta divided by 2g, just plug in the formula, is equals to so I have written this formula for the H max. So let's write it for the range first. So it is going to be u square sine 2 theta is like 2 sine theta cos theta divided by g, and that should be equated to u square sine square theta over 2g. So when we equate these, the factor of u square is going to cancel out, g is also going to cancel out, and the value of tan theta will turn out to be 4. So theta is equals to tan inverse 4. So the correct answer should be option A, my dear students. Right. So the next question is from 8th April shift 2 attempt of 2024. A body of mass m is thrown horizontally with a velocity v from the top of a tower. So let's first put that down. So velocity v from a tower of height h. See, the mass is given just to confuse you, because in kinematics this gravity, the acceleration due to gravity, we have understood now, does not depend on the mass of the particle, right? So we are talking about the range. So this range is given as 100 meter. Now this is a question of a horizontal projectile. We do understand that the range is going to be how much, my dear students? V under root of 2h by g. Why so? Because the velocity is like v and the time of fall is like root 2h by g. So this range is given to be 100 meter. Okay, now they've changed things. Now a body of mass 2m, so we'll ignore the mass part because the acceleration does not depend on mass, is now thrown from a tower of height 4h is what we know, but with a velocity, let's say v by 2. Okay, now where will it hit the ground? Now what is going to be the new range? So let's say here, okay, so this new range, let's call it like r dash. So this r dash is going to be how much, my dear students? So now the velocity of projection is like v by 2 and the time of fall is like root 2h by 4 divided by g. So instead of h I have written instead of h I should be writing 4h, okay, and yeah, so now it's all correct. So we have an extra factor of 4 in the root, so that will become 2, and there is a 2 outside, so they will cancel out, and ultimately what you will realize is that it's a compensating effect, and ultimately the new range that you're going to get, that is r dash, is going to be the same as the previous one. So the correct answer is going to be 100 meters. Why? Because the effect got nullified. Why it got nullified? That's because if you made the velocity half, the time became 2 times, and ultimately the distance is speed into time in x direction, because there is no acceleration, and hence the range is still the same, that is 100 meter. Alright students, so the next question. Next question is from 5th April shift 2. A man carrying a monkey on his shoulder does cycling smoothly on a circular track of radius 9 meter and completes 120 revolutions in 3 minutes. So first let's put this down. 120 revolution in 3 minutes is like 40 revolutions per minute, or RPM. Now let's convert omega to a radian per second. So we do understand that 1 revolution is like 2 pi radian, and if it's like per minute, so for per second we will divide it by 60. So this is like 2 by 3, so it's going to be like 4 pi by 3 radian per second. So now we've converted this to SI unit. Now what we need to do is, they are talking about the magnitude of centripetal acceleration. All right, so it's going to be like omega square r. I hope you understand that. Now omega square is going to be 16 pi square divided by 9, and the radius is also given to be as 9. So 9 cancels out, and this becomes 16 pi square meter per second square. So the correct answer is clearly option D. Right students. So the next question is from 5th April shift 2. The maximum height reached by a projectile is 64 meter. If initial velocity is halved, the new maximum height would be. Can't get easier than this. Just in a minute we can solve this, not even a minute. So it's like u square sine square theta over 2g, and this height is given to be 64 meter, right? Now if you are making the velocity half, because it is depending on square, the new height will of course become what? Divided by 4, right students? Because if you make the velocity half, squaring that will make this by decrease this by a factor of 4. So h by 4. So the correct answer is going to be 64 by 4, and that is going to be 16 meters. So the numerical answer that you have to plug in here is 16. Right students? So the next question. Okay. So this is from 4th April shift 1. The coordinates of a particle moving in the xy plane is given by x is equals to 2 plus 4t and y is equals to 3t plus 8t square. The motion of the particle is. Alright, so let's quickly do this. How? Let's first differentiate, then this is going to give us the velocity in the x direction, so that's going to be like 4, and velocity in the y direction is going to be like 3 plus 16t. We differentiate it further, so we get acceleration in the x direction as 0 and acceleration in the y direction as 16. So clearly it's showing that the acceleration is uniform, it's constant, it's not changing with time because there is no term of time left here, right? And how about the trajectory? Because the options state whether it's a straight line or a parabolic path. So let's do one more thing. Let's eliminate time from the two equations. So I would write y is equals to 3, and time I can write as x minus 2 divided by 4, right? X minus 2 divided by 4 plus x minus 2 divided by 4 whole squared. Since degree of y is 1 and degree of x is 2, so this trajectory is a parabolic trajectory. Now we have ample information to try the options, to go through the options. So uniformly accelerated, having motion along a parabolic path looks absolutely right to me. Of course it is uniformly accelerated and is also following a parabolic path. Uniform motion, no, it's not uniform motion. Uniform motion means velocity or let's say speed constant. That's not true. Along a straight line, again not true. Uniformly accelerated, true. Having motion along a straight line, not true. Non-uniformly accelerated, no students. Acceleration does not include a term of time. Hence, acceleration is definitely constant or uniform, and it's not non-uniform. So the correct answer is of course option A. Right students, so the next question. Next question is from 1st February shift 1. A particle moving in a circle of radius r with uniform speed takes t time to complete one revolution. So it's like time taken to complete one revolution. So t is of course 2 pi r over v. So we can write v is equals to 2 pi r over t. That's the first thing that we can note here. If this particle is projected with the same speed at an angle theta, the maximum height attained is equal to the value of 4r or 4 times that radius. So let's do that. H max is equals to v square sine square theta over 2g, and this H max is given to be 4 times r, and this is like 1 by 2g, and instead of v square I will write 4 pi square r square divided by t square into sine square theta. So I've done my bit. I've just substituted the values. 1r and 1r factor cancels out, 4 and 4 cancels out. This gives me sine square theta is equals to 2gt square and divided by pi square r. So if this is sine square theta, then sine theta is going to be under root of this, and then theta is going to be sine inverse of that. So it's like sine inverse 2gt square divided by pi square r power half, which looks exactly like option A. So nothing much to be done here. Probably they were just trying to mix the concept of circular motion and projectile motion. Right students, so the next question is from 29 January shift 1. If the radius of curvature of the path of two particles of same mass are in the ratio 3:4. So let's first interpret that very quickly. R1 is to R2 is like 3:4. Then in order to have a constant centripetal force, okay, so they should have the constant centripetal force, means they should have equal centripetal force. Their velocity should be in the ratio. Now what is the formula for centripetal force, my dear students? Since centripetal acceleration is like v square by r, so centripetal force is going to be like mv square by r. So mv square by r is equals to mv square by r. That's what I am doing. So v1 over v2 is equal to like under root of r1 over r2, so is like under root of 3 by 4. So that's going to be like root 3 is to 2. Very easily you can do this. I don't see any problem whatsoever. I hope you know centripetal acceleration is v square by r, and therefore force is equals to mass into acceleration. Hence it is mv square by r, but don't need to worry about the term of m because mass is same for both the particles. Right, students? So the next question, in fact this is the last question of this series today that we are discussing. 29 January shift 1, a ball rolls off from the top of a stairway. So we have done many questions of stairway in our theory classes. So this is what is happening. Okay, the steps are 0.1 meter high and 0.1 meter wide. The minimum velocity u with which the ball just hits the should be projected so that it hits the step 5 of the stairway. All right, so this is like not the stairway starting, it's like 0th step. This is like the first step, this is like the second, third, fourth, and we wanted to hit this step. So this point becomes crucial for us. Why? Because we want it to cross this point, because if it crosses this point, definitely it's hitting the 5th step. Right, students? So the good part is that height and width both are given to be the same. So in a way it's a question of horizontal projectile. So how much should be the range? 1, 2, 3 and 4. So the range is going to be 0.4 meter. What about the height? 1, 2, 3 and 4. Oh, so the height is also 0.4. So this is what we have interpreted out of the whole language. Now you do understand that the formula for range is u under root of 2h by g. Now the range is given to be 0.4 and u is what we have to find out, and h is also 0.4 for this to happen. Like this is the minimum speed, so square both sides. So this becomes 0.4 into 0.4 is equals to u square, and this is going to be 2 into 0.4 divided by 10. So one factor of 0.4 cancels out. 0.4 into 10 becomes 4. 4 divided by 2 is 2. So u square is equals to 2. So u is equals to root 2. And they have given us as root x. So the numerical value of x that we are going to fill here is going to be 2, my dear students. So no problem whatsoever. I think this is easily manageable, and you should be able to do all such questions. JEE Mains is like that mostly now, that you get straightforward questions, and that is why the cutoff is quite high. But it's a competition, so if it's easy for all. You just need to be very temperamentally strong and very confident while you're attempting the questions. So I hope these videos are also giving you that confidence that we are trying to achieve for you. So we'll keep coming up with such more videos which can help you ace your exam. But that's all for this particular video, students, and I will see you very soon. Bye bye. If you enjoyed this video, please don't forget to like, share and subscribe to our channel.